me, for this trig graphing, this could get quite interesting as I attempt to make these graphs on this tablet. So we will try our best. All right, first of all, I think we've made progress in these. I'm going to try to make sense of them, rewind them, watch them as many times as you want, but I think this should really help you. Now remember, the way we're graphing these is we're only graphing one period, okay? So you're really not seeing to scale the differences, the transformations that are happening. So keep that in mind as we do this, all right? So looking at this first one, the amplitude is actually 2. The amplitude does make sense. We have defined the amplitude as half the distance from peak to peak of our wave. So that would be 2. From the main axis to the peak is 2. Okay, so looking through this, we actually have a vertical shift of nothing here because there's nothing tacked on to the back. So I'm going to say 0. The phase shift is going to go to the right pi over 4. Just like we've done transformations in the past, this actually shifts the graph to the right when it says minus pi over 4. Okay, the period is always 2 pi, except if there's somewhere, let me get a highlighter here, unless there is something right here. And since there's no number other than 1 right there, it actually is going to be a period of 2 pi. So what does this mean? All right, well, I'm just going to draw an axis here. That's the way I've been doing them. Every teacher does it a little different way. But if I leave this right here, that means I'm going to actually start my graph at pi over 4. So I've been doing that. And then that means I'm going to end my graph 1 period later. Well, 1 period later would be 2 pi later. So we need to add 2 pi. Now, if you're starting at pi over 4 and you're going 2 pi later, it's literally like taking pi over 4 and adding 2 pi. Well, here's the deal. We want a common denominator of 4. So how do I get this to say 2 pi? How about 8 pi over 4? That does say 2 pi, just with a common denominator. So that gets me my endpoint at 9 pi over 4. So that's right here. Okay? I also talked to the unit circle, people that really understand the unit circle. If you're starting at pi over 4, you're going to go around and end at 1 pi over 4 bigger than 8 pi over 4, so 9 pi over 4. And you unit circle people can probably get that the halfway point here would be 5 pi over 4. But if you're not doing that, some of you are doing this thing called add the tops, 10 pi, double the bottoms, 8. It's going to reduce to 5 pi over 4. Whatever method you use, you have to find the middle. Okay, pi over 4 plus 9 pi over 4 is 10 pi over 4. But you need to divide that by 2. So that's why we double the bottoms in that case. Okay, between 1 and 5, the midpoint here is going to be 3 pi over 4. Okay, so hopefully these people that are doing the unit, you started at pi over 4, 1/4 of the way would be 3 pi over 4, right? And then it would be 5 pi over 4. And then what would this be in between here? 7 pi over 4. If you're adding the tops double than the bottoms, 5 pi and 9 pi, 14 pi over 8 reduces to 7 pi over 4. All right, so on this one we need to be careful. There's no vertical shift, so this y-axis here is going to be at 0, but we're going to go up to 2, and we're going to go down to -2 because of that amplitude. Okay, and then now I'll switch gears here, and with red, now what? Cosine graph, where does that start? I always forget. Remember, love the unit circle. If I go back to the quadrantals, that ordered pair is 1, 0. What is a cosine at that location is 1. So that tells me you start at 1. Now obviously it's 2 here because of the amplitude change, but it means you start up here. So you start right there. And then what happens as we go through, this is something hopefully we've kind of got down by now, but the progression of a cosine graph, at least for one period, it looks like this. So we're going to actually solidify our graph. Oh yeah, nice. Okay, just like that. So basically, did we account for the phase shift? Yes. Did we account for the period? No change to the period, but we got to 9 pi over 4. We found our checkpoints, and this is what the answer should look like here. Okay? All right, let's move on and try some more, see what differences happen as we go through these. Number 34 is cosecant. So I automatically just kind of make a note to myself that I remember we're doing a sine graph. All right, let's try blue here. Amplitude, I'm going to say, is not applicable for this one. The reason it's not applicable is the definition doesn't fit of amplitude, and we're not flipping, we're not stretching, so there's not much to do here. Vertical shift, down 3 because of this here. Phase shift, we're going to go to the right, pi over 2. The period for any sine graph, which is the reciprocal of cosecant, and cosecant is 2 pi. No change to this one. So again, my unit circle people, I hope you like this. You're going to start at pi over 2, and you're going to go one time around back to here. So you're going to start right here at pi over 2. Well, that would be 2 pi over 2, 3 pi over 2, 4 pi over 2. Actually, 5 pi over 2 is going to be your ending point. Okay, if you don't like what I just said, don't worry. You could always go back to the starting point, which is pi over 2. And you can take that phase shift, which is the starting point, and add the period to it. So if I do that, pi over 2, and add the period, that would be 4 pi over 2. That's going to get you to 5 pi over 2 when you work through your common denominator. All right, so I'll speak to you at the top, double the bottom, people. Add the top, 5 pi, pi is 6 pi. Double the bottom, it's 4. 6 pi over 4 reduces to 3 pi over 2. My unit circle, people, here's pi over 2. Halfway around would be 3 pi over 2. Okay, and then the quarter of the way would be just pi. Add the top, double the bottom, you'll get 4 pi over 4, which is pi. And then this spot right here, if we're going back around, is actually going to be 2 pi. Unit circle, people, it's right here. Add the top, 8 pi over 4. 8 pi over 4 is 2 pi. Okay, so I've set up the x-axis. Now the y-axis, let's take a look at that. Now I'll do that in green. We did do a vertical shift down 3. So this is where I'm kind of cheating here, and I'm just putting a -3 right here. You're not going to actually see it change by this method. The amplitude is not applicable, but there is a 1 out front. That just means that you're going to go up here. Careful, they're negatives, to -2. And you're going to go down here to -4. Okay, so in green, I'm going to sketch this graph. Excuse me, it is a sine graph. So we are going to start right here. There's no flip or anything, so it's just going to go up, carry down through, down to here, back up to here. And I am going to do a dashed reference line. You obviously don't have to draw this in, but it does help you there. So there's my dashed reference line, and then I'll take a different color, red here, and you'll actually see, actually let me go back to green. Oh, I never changed, so I'm good. You're going to have asymptotes for a cosecant graph, and it's going to be wherever we have 0. Love when you make this connection. The value of sine right there that I'm pointing at is 0. So if I took the reciprocal, because that's what we're doing here for sine and cosecant, if I took the reciprocal of that, a 0 would go to the bottom and be undefined. So anywhere there's a 0, we're going to be undefined at that location. Okay, so if we graph just one period, we're actually including that point, and it's going to look just like that. Done and done. Okay, hope that helps. Let me go try another one, number 35. Oh, we gotta think about that 2 right away. So we gotta pull out that 2. So y is equal to sine 2, and then we wanna have on the inside x minus pi over 2, because we wanna factor out the 2. Okay, the amplitude is gonna be 1. The vertical shift is nothing. The phase shift is pi over 2, right here again. The period does change. It's normally 2 pi, but this time I actually have that number here, right? 2. So that's the denominator. So 2 pi is what we normally have for a sine graph. We're going to divide by 2, and our period is going to be pi. So we are going to start this guy at pi over 2. Okay, again, I just love thinking of the unit circle, sorry. But this is the starting point right here. The ending point is only pi later. 1 pi later is the ending point. So you can just look there and get that that's 3 pi over 2. If you actually worked it out, phase shift, pi over 2, plus pi, which with the common denominator is 2 pi over 2, it gets you right back to 3 pi over 2. So where's our starting point for this one? It's going to be pi over 2. And then we're going to go over here to the ending point of 3 pi over 2. So where's that halfway point? Love it if you're thinking unit circle, because that's just pi, right? But if you add the tops, double the bottoms, that's 4 pi over 4, which is here. If you just put this here, then you'll have a hard time possibly adding the tops, doubling the bottoms. So I do want to speak to that right now. We are talking about the quarter of the way point. So if you look over at my unit circle, we're talking about like this point right here. But if you're not comfy with the unit circle, I would wisely, or I guess I don't know what I was trying to say, but I would suggest you think about it like this, 2 pi over 2. That is pi, but now you have the same common denominator, so you can add the tops, 3 pi, double the bottoms, and get 4. That's exactly where that little red tick is over there, because that's 1/4, 1/2. Then this one here would be 4 pi over 5 pi over 4. So again, you can add the tops, double the bottoms, but you need to be able to find those checkpoints for me. Okay, so I've got 5 pi over 4. Now amplitude is 1, so we're going to go just up to 1, and we're going to go down to 1. Not a lot of crazy stuff going on this graph. It's a sine graph, so we're going to start on the graph, and we're going to go up, back, down, and up again. So sine graph, whoops, sorry, hope you get the idea. It's hard to graph with this pen, but that's our sine graph. For that one. Okay, moving along, I got a secant here, and then we got some tangent, cotangent to finish strong. We are going to have, as I see in here quickly, we are going to have a vertical shift of up 1. Okay, we are going to go up 1 because of this. The amplitude is not applicable. That's only making sense on sine and cosine ones. This one is like a cosine, so we like to think that. Maybe if we're making a note to ourselves right now, just know the 2 is going to affect how we stretch this. The phase shift is none. Gotta love that. The period is 2 pi, but wait, the period is actually 2 pi divided by 3, because that number, remember right there, actually, hold on, that number right there affects the period. That's the denominator on the period. Okay, so we're going to start at 0, and we're going to end at 2 pi over 3. So if I start at 0, end at 2 pi over 3, I'm going to tell you right now, I'll be honest, looking at that unit circle, this might even be a little bit tricky for people to come up with. I'm not sure. But this would be the halfway point from 0 to 2 pi over 3. So if you think about this mathematically, that's really 0 over 3. Add the top, double the bottom, 2 pi over 6. That's really 1 pi over 3. I do think you guys are good enough to figure out from 0 to 2 pi over 3, the halfway point would be 1 pi over 3. Okay, but that might help you now to be like, all right, add the tops, pi, double the bottom. That's actually going to be pi over 6. Add the tops, 3 pi, double the bottom, 6. That's going to be pi over 2. Okay, so a little bit trickier one. You definitely can think of the unit circle for sure on that one, but you should be set up like so. Okay, so now we know the amplitude is not applicable, but we're going to rise to 2. So we're going to rise to 2. Now here's the problem. Your vertical shift was also up 1. So actually, this main axis here is up 1, which means this is going to be 2, 3, and then it's going to drop down to -1, to 0 to -1. Again, we're not drawing these perfectly to scale. We're not showing the shift, so be careful there. This is a cosine graph. There is no flip on this one. It's a cosine graph. Cosines start up here. So this cosine graph would look like that. And like we said before, you're going to take anywhere there's a 0, and you're actually going to draw in your vertical asymptotes there. Okay, so now I'm going to take, let's go with blue here, and I'm actually going to sketch my graph, which it's hard to do here because I'm running off, but it's going to be there. We're going to share this point, and it's going to have that tendency towards the asymptote, and then this tendency towards the asymptote there. So I'm just going to always refresh and be like, all right, I accounted for the 2, the 3 was the period change, got it, phase shift nothing, did go up 1. Looks like I took care of everything, and got the right answer to that one. Okay, we have tangent and cotangent left. Now, with tangent and cotangent, they are different. because they don't take as long to repeat. The period is only pi for these, and we graph them accordingly. So the amplitude here really doesn't make sense. So the amplitude is not applicable. I'm going to go back to black for this one. The amplitude is not applicable. The vertical shift, no, nothing going on. Phase shift, hopefully we're getting the hang of that now. That would be right, pi over 4. The period isn't affected, but it's normally pi, so we have pi there. So I'm going to start at pi over 4. Give the unit circle a chance here. Pi over 4 is here. One trip around. Wait, not one trip around, just pi around would put me right here. So that's actually 5 pi over 4. And we've also said that you can obviously, 5 pi over 4, that you can do your starting point, pi over 4. I'm explaining this each time because I don't know if you guys are watching every question, but it's good repetition. Pi over 4 is the phase shift, and then we add pi to that. Well, pi is 4 pi over 4 with a common denominator, again, 5 pi over 4. So, whoops, there we go. This is actually going to be pi over 4. And then the ending point, which we just found, is 5 pi over 4. And since we're only a period, we only need to get to the midpoint here, okay? There's less quadrantal checkpoints. So basically, pi over 4, 5 pi over 4, that's going to get you at 3 pi over 4 for the middle there, okay? And now this is a tangent graph, okay? This is a tangent graph. So if you're like, I can't remember, I love that we can go back to the quadrantal. This is the ordered pair, 1, 0. Tangent is sine over cosine. Tangent is actually 0 at the first location. So think back to what tangent graphs normally do when they start. They're at 0. So this is actually 0 here. Okay, well then we move up to the first checkpoint, and that actually becomes, undefined there. And then we get back to 0 here. Well, then you have your question of, all right, well, does it go up or does it go down? Well, think about what happens between, I know this is a small drawing, but between the first and the second checkpoints. Now, here's what I got to say. I know that these are different. These say pi over 4, 3 pi over 4, but that's just because it has a phase shift. The tendencies can be found right here. So a tangent graph starts at 0. But it goes to its first checkpoint. Everything's positive here. So any tangent is positive. So that means between these two checkpoints, all of the values are going to be positive. Whereas between the next two checkpoints, we're going to have, if you drew a triangle in here, you'd have an opposite and an adjacent, which would be a positive over a negative value. So that would be here. Okay, just so you're clear, I did exactly what a tangent graph does. But I'm going to back it up. Well, I'll show you, because this is a -2 here. So we'll back it up and we'll undo, those two graphs, because we need to do the reciprocal. We need to flip that is what I meant to say. So normally it goes up, so now it's going to go down right here and up right there. Now, I'm not going to lie to you, your vertical stretch here is 2. You're not going to see much of a difference when you do that the way we're graphing, but it does have a 2 for the vertical stretch. Okay, I got to finish strong here. Here we go. Cotangent. Amplitude, not applicable. Okay? Vertical shift, yep, up 3. Phase shift, no thank you. Period, pi divided by 2. So we're going to start at 0 and we're going to end at pi over 2. So just think to yourself, what's the halfway point between 0 and 1/2? And that would be 1/4, or pi over 4. Okay, now this is a cotangent graph. So just like we were saying before, what happens at the starting point? Well, think about this. If tangent is 0 over 1, 0, cotangent would be 1 over 0, undefined. So what that means, I'll grab a different color here, is that at the starting point, we actually have a vertical asymptote, which is why we have one over here as well. And then what happens at that first checkpoint? So we're undefined here, we're undefined here. What happens at this checkpoint? Well, that's the order pair 0, 1. Cotangent is going to be cosine over sine, so that's actually 0. So then you say, okay, well, what happens between the first and the second checkpoints here? Everything's positive. So up here, things are positive. And then between the next checkpoints, please relate these as to 0, pi over 2, pi over 4. I'm sorry, 0, pi over 2, pi. But over here, there's 0, pi over 4, pi over 2. It's just the checkpoints. Don't mean to confuse you. If you guys want to memorize, that's totally fine. Look at what a cotangent graph does with its tendencies. But between 0, the first 2 checkpoints here, you are actually going to have positive, positive, positive stuff. So that means you're positive here. So a cotangent graph goes up like that. And then between the next 2 checkpoints, you're going to have the graph go down. And I drew that a little far away. That should probably hug the asymptote a little bit, okay? What I would do, though, is I would make sure you understand, like a tangent graph, if I go back to here, and I'll do this in yellow, a tangent graph, pretend this doesn't say -2 up there, a tangent graph normally goes up right away, okay? What does a cotangent graph do? It is positive right away, but it's going in the other direction, okay? So just memorize your tangent graphs. Like yellow there, that's a tangent graph. Red is the flipped tangent graph. This right here is cotangent. If it was flipped, it would go in the other direction. Okay, I hope this helped. Good luck. Keep studying.